Greetings to every one of you. So in this video we are going to discuss a topic from operating system, that is CPU scheduling using first come first serve policy. What is CPU scheduling? It is a method by which one process is allowed to use the processor while the other processes are kept on hold or wait state. The operating system selects one of the processes from the ready queue and allocate the processor based on the policy. If you take a process, the process may have the different states, like one is ready state and another is the run state or execute state. Then you will have the wait state. After wait state, again it come back to the ready state. So here the process may be waiting for some IO to be complete, required for IO operation. So once if the IO is completion of IO, it back to the ready state. So from the ready state to the run state, so only here we need this scheduling. So which process will be that is allocated, okay, which process will get the processor, and that is decided by the policy. So only for that portion we need this scheduling algorithms. There are different types of scheduling algorithms. Mainly they are categorized into two types. One is called preemptive and another is non-preemptive. In case of the preemptive, the process may be that is removed before its completion, depends upon the policy from the processor. But whereas in non-preemptive scheduling, the process will be in the CPU, the processor, till its completion. So very good example for non-preemptive, it is the first come first serve. So until its completion it will be remains in the processor. But whereas in the preemptive scheduling, before the completion, depends upon the policy, the processor may remove, the operating system may remove the process from the processor. Okay, very good example for that, it is round robin method. So here this problem is given, and most of the examination, like the NET or the SLET examination, this kind of questions are asked. So this is a problem that is given. We have 5 processes and their arrival time and burst times are given, and we have to that is calculate the turnaround time, the waiting time, average turnaround time and average waiting time, that we have to calculate. So this is the problem. So how to solve this? First of all, see here, this can be that is represented in the form of a Gantt chart. It's a Gantt chart in which we can just represent all these the arrival time and based on the burst time, the process, how the process will be that is get executed one after the other. That can be represented with the help of this Gantt chart. Okay, let us see how. So just to compare, these are the processes, that is we have 5 processes, and these are the arrival times. Just everything is given in milliseconds. Okay, so just to compare what time actually which is the first process come first, because we are using the policy first come first serve. The process which comes first, that will get the processor first. So that is our policy. So comparatively here the process 2 arrives at 0 milliseconds. Okay, 0 at time 0 we received the process 2. Okay, so the process 2 arrived at 0 millisecond and its burst time is 2 milliseconds. So by that is 2 millisecond, the process 2 is over. So during that time, if any other process that is arrived, that we have to check. So 0 to 2, that is no process, that is at 2 millisecond we have got this process 1. So process 1 that is arrived at 2 milliseconds. So again its burst time is 4 millisecond. So just you add, that is 2 plus 4, that is at 6th millisecond the process 1 is over. Okay, so process 2 is over and process 2 is that is process 1 2 is over and 1 is also over. So now the process you check any other process that is arrived in between 2 to 6. So yes, we have process 3 arrived at 3rd millisecond, and during the 4th millisecond the process 5 arrived, and 5th millisecond actually the process 4 arrived. So the order just I have indicated here. So the process 2 is first and process 1 that is second. Process 3 came 3, that is now process 3, its burst time is 3, that is 4 milliseconds. So 6 plus 4, that is 10th millisecond, the process 3 is over. Now the priority goes to process 5 because it arrived at 4th millisecond. Okay, so process 5 we have to that is consider, and its burst time is 5 milliseconds. So 10 plus 5, that is 15th millisecond, the process 5 it is over. Now move on to, that is the 5th priority goes to process 4. The process 4 that is arrive at 50th millisecond, and again its burst time is 3. So at 18th millisecond the process 4 is over. So this is the Gantt chart we can prepare from this the given chart. Now let us see how to calculate this turnaround time. So turnaround time can be calculated as completion time minus the arrival time. So completion time, it is 6, arrival time is 2, the difference is 4. 2 minus 0, it is 2. 10 minus 3, it is 7. 18 minus 5, it is 13. So this is 15 minus 4, it is 11. So this is the turnaround time. So now we can calculate the waiting time. The waiting time can be calculated like subtract the burst time from the turnaround time. So it is 4 minus 4, it is 0. 2 minus 2, it is 0. Then 7 minus 4, it is 3. Similarly 13 minus 3, it is 10. This is 11 minus 5, it is 6. Okay, so this is how we can calculate the waiting time. There is one more thing is available. It's what is called a response time. Some of the schemes they used to ask this particular question. What is how to calculate the response time? So response time, it is starting time minus arrival time. You can say that when the processor allocated to the process very first time. So that is the starting time of the process. Okay, so the starting time of the process, that is P2, is 0, and 0, that is that's a starting time, and the arrival time is also 0 for process 2. So it is nothing but 0 minus 0. So similarly for process 1, the starting time is 2. 2 minus 2, it is 0. Similarly, the starting time for process 3, it is 6. 6 minus 3, it is 3. Similarly, the next process is process 5. The starting time of process 5 is 10, but the arrival time is 4. So the difference is 6 for process 5. Similarly, for process 4, the starting time is 15, and the arrival time is that is 5. So you got that is 10. So if you compare the last two columns, that is waiting time and response time, so both are that is similar in this case. Okay, but if you take the preemptive scheduling, in which they will have the different values. So as for the non-preemptive scheduling, you will have this waiting time as well as response time, both are equal. So this is one one of the questions used to ask in the NET examination. Okay. So now from this we can calculate the average turnaround time, average waiting time, average response time. So for example, it is nothing but summation I is equal to, that is 1 to n, just Ti divided by n. So where Ti is the turnaround time, and n represent this number of the processes. So if you calculate, the sum is 20, 31, 37. So it is 37 divided by, that is 5, which is equal to, that is 7.4 milliseconds. That is the turnaround time. Similarly, the waiting time you can calculate, it is 19, that is summation of I is equal to 1 to n, that is waiting time divided by, that is n. That is 19 by 7, which is equal to, that is 3.8 millisecond. Okay. So both this waiting time and response time, both are same. Okay. That is Ri by n. That is a summation I is equal to 1 to n. This is also the same, 3.8 milliseconds. So in this video we discussed about what is process scheduling, what are the different types of scheduling, and also just with the example I just explained how to, that is calculate the completion time, turnaround time, then waiting time, response time, and their average. Thank you.